I'm starting with the dataset description. We have 12 samples in total, neatly divided into 4 groups. Importantly, each group contains the same number of samples, 3. This even distribution is key to understanding how the "LeavePGroupsOut" cross-validation works. This line specifies the scikit-learn function I'll be using. "LeavePGroupsOut". The "n_groups equals 2" part tells us that, in each iteration of cross-validation, I'm leaving out 2 entire groups from the model training. Think of it like this: I'm testing the model on 2 groups and training on the remaining 2. I'm using a special type of cross-validation called LeavePGroupsOut. This is perfect for situations where my data is grouped, and I want to make sure samples from the same group are either all used for training or all used for testing. This avoids data leakage and ensures fair evaluation. This is the core question. I'm assessing my understanding of how "LeavePGroupsOut" creates the training and testing data splits given my dataset characteristics. Statement A states that I'll get exactly 6 different data splits. I'll check if that's true by working out the combinations. I'll use the combinations formula to confirm this. This statement says that in each split, I'll have 6 samples for training the model and 6 for testing it. I'll verify this based on the number of groups and samples per group. Let's dive in. Here, the claim is that every single sample in my dataset will appear in the test set exactly twice across all the splits. That's a key point to verify. Statement D claims that the order of the groups left out for testing will be the same across all splits. I need to determine if that's guaranteed by "LeavePGroupsOut" behavior or not. I'm using scikit-learn's LeavePGroupsOut for cross-validation. It's a special method for dealing with data split into groups, ensuring that all samples from the same group are either in the training or the test set. I have 12 data points, nicely organized into 4 distinct groups, with 3 data points in each group. Think of it like sorting candies by color: 4 colors, 3 candies of each. I'm using LeavePGroupsOut and telling it to leave out 2 groups at a time during each cross-validation split. If I have 4 groups, and I choose to leave out 2 at a time, there are 6 ways to do this. I calculate this using the combinations formula. 4 choose 2 equals 6. Think of choosing 2 groups out of the 4 available. Each time I run a split, I'll have 6 samples for training, the ones in the groups I didn't leave out, and 6 samples for testing, the ones from the groups I did leave out. Since each group is part of 2 different pairs of left-out groups, every sample, all belonging to those groups, winds up in the testing set exactly twice across all 6 splits. The training set will consist of the samples from the groups not left out in a given split. That will always be 6 samples. The test set will contain the samples from the 2 groups that are left out during that particular split. This amounts to 6 samples each time. I'm using LeavePGroupsOut to do cross-validation. This is a special method for dealing with data grouped into categories, ensuring that all samples from the same group are either in the training part or the testing part of the split. It's like making sure all your apples stay with your apples and oranges stay with your oranges when sorting out your fruit basket for a recipe. I have 12 data points divided into 4 groups. Each group has 3 data points, which helps me with setting up the cross-validation. I'm using the LeavePGroupsOut function with "n_groups equals 2". This tells the function to leave out 2 groups when creating each split for testing. For example, I might pick Group 1 and Group 2 as the test set in a particular split, and use the remaining groups to train the model in that split. The question asks which statements are true about the cross-validation splits I'm creating. It tests my understanding of the LeavePGroupsOut function's behavior. I'm calculating the number of ways to choose 2 groups out of 4 for the test set, which is 6. I need to select 2 out of 4, which can be computed by this formula, 4C2, which gives me 6 possible splits. This statement is true. Since each group has 3 samples and I'm leaving out 2 groups, 6 samples, there are always 6 samples left for training. This means each split contains 6 training samples and 6 test samples. This statement is true. I'm evaluating whether every sample appears in the test set exactly twice. Since we have 6 unique ways to choose 2 groups, and every sample belongs to a group and every group is included in exactly 2 test sets, then every sample is included in exactly 2 test sets. This statement is also true. The LeavePGroupsOut function doesn't guarantee any specific order when selecting groups for testing. It just makes sure I have all the possible combinations. So, the order of groups in the test sets won't be consistent across splits. This statement is false. I'm using LeavePGroupsOut, a scikit-learn tool for a special type of cross-validation. It's perfect when I have data grouped, and I want to make sure that all samples from the same group are either in the training set or the test set, never split between the two. Imagine I have 12 items, sorted into 4 boxes, with 3 items in each box. This is my dataset, 12 samples, organized into 4 groups of 3. In my cross-validation, I will leave out 2 entire groups at a time. NGROUPS simply means number of groups. It is set to 2. With 6 items out in the test set, the other 6 will be in my training set. Therefore, each split will have 6 items for training and 6 items for testing. The training set and test set will both have the same size, 6 samples each. The training set and test set will both have the same size, 6 samples each. The order in which I leave out groups is not set in stone. LeavePGroupsOut doesn't pick a specific sequence. It considers all possible combinations. I won't always leave out the same groups first. The order changes across different splits. To figure out how many different ways I can leave out 2 groups from 4, I use combinations. That's 4 choose 2, or 4, 2, * 2, equals 6. I will have 6 different splits. A mathematical way to say 4 choose 2 inches is 4C2. This means the number of combinations when selecting 2 items out of 4. This equals 6. Because I'm leaving out all samples within the groups, each of my 12 samples will end up in the test set exactly twice during this whole cross-validation process. Every one of my 12 samples shows up in the test set exactly twice across all 6 splits. We're using a scikit-learn tool called LeavePGroupsOut to do cross-validation. This is a special way to split data when you have groups of related samples and you want to make sure that samples from the same group are either all in the training set or all in the testing set. Think of it like making sure all students from one class stay together in their assigned groups. I have a dataset with 12 samples that are divided into 4 groups, with 3 samples in each group. I am treating each group as a distinct unit. I'm using LeavePGroupsOut with *n_groups equals 2 *. This tells the function to leave out 2 groups in each split during cross-validation. Based on how I'm setting up the cross-validation, we need to figure out which of the following statements about the splits are correct. Let's determine the number of ways to choose 2 groups from 4 groups, which is equal to 6. 4 choose 2 equals 4. 2 * 2 equals 6. That's how many splits I'll generate. Since I have 12 samples and each split leaves out 2 groups, 6 samples. This means there are 6 samples remaining, which make up the training set. Each split will have 6 training samples and 6 testing samples. Perfectly balanced, as all things should be. Because each group is left out in combination with other groups, there are 6 combinations. Every sample will appear exactly twice in the test set. LeavePGroupsOut does not guarantee a specific order of groups in the test set. The order is determined randomly by the combinations, not a predefined sequence. I'm using scikit-learn's LeavePGroupsOut, which is a special cross-validation technique. It's perfect for data where you have groups of similar things, and you want to ensure that all members of each group end up together either in the training data or the testing data. Think of it like this. If you are testing a new drug, you might want to make sure all members of a family are either in the treatment group or the control group, not spread out across the two. I have 12 data points total, neatly divided into 4 groups. Each group contains 3 data points. I'll have 6 different ways to split the data. This is because I'm choosing 2 groups out of 4 to be my test set. The number of ways to choose 2 groups from 4 is calculated as 4, 2. Asterisk 2. Which equals 6. That's 4CHOOSE2 in mathematical terms. In each of those 6 splits, I will have 6 samples in the training set and 6 samples in the testing set. This is because each group has 3 samples, and I'm leaving out 2 groups. 2 times 3 equals 6 samples, for testing. The remaining 6 samples form my training set. Each data point appears in the testing set exactly twice. This happens because each data point belongs to a group, and every group is left out in combination with every other group during this cross-validation process. The order of groups in my test set will not be the same across all 6 splits. The order is not predetermined. LeavePGroupsOut simply generates all the possible combinations. It doesn't force a specific sequence.